Okay, so critical path analysis is quite a big chapter in D1, and essentially it's about problem solving when you've got lots of jobs to do, and some of the jobs depend on other jobs, so you need to finish some of the jobs before you start the next job, and it's about how quickly can you get all the jobs done, how many people do you need, how long will it take, what could go wrong, that sort of thing. Okay? Right. So this is an example of an activity network, and this is how we lay out the situation where we've got a load of jobs and they depend on each other, but obviously there's different dependencies. So if you look at this network, you should be able to relate it to the information. So for example, activity C here is coming out of here, and this can only happen after A has happened. So activity C can't start until activity A has been completed. So something like activity G here, activity G can't start until F and D are both completed. So here's F being done, here's E being done. When they're done, G can kick off. Does that make sense?
What about D to H?
D.
Oh, because F is connected. Yeah.
D what? D. When D is finished, H can go. Yeah. Okay. So these boxes, these are called events, and in each of the boxes we put two numbers, and the top number is the earliest. It's like a whistle saying, right, next thing can start. So, for example, A can just go, so we could put a 0 in here because it can just start straight away. Now, B and D and C here are waiting for A to finish. So the absolute earliest they can possibly go is time 2. I mean, maybe they could go at time 2, but they have a cup of coffee and they start at time 7. But they definitely can't start before time 2. On the other hand, if we're going to finish by a certain time, so say, for example, that we're going to get the whole job done in 10 days, so this is getting the job finished in 10 days, well, activity H is 3 days long. So activity H, the absolute latest that could start is day 7, because otherwise it's going to finish past day 10. So the top ones are the absolute earliest that this event could happen, and the bottom ones are the latest the event could happen, and the event is saying that the jobs leading into it have been completed, so the next set of jobs can start. So that's what an event is. Okay. So when we're doing a forward pass through the network, we're only looking at the early starts. So for example, we've got an event here in isolation, and we've got this number 3, time 3, this whistle goes, and then that says that job A can go. Job A is length 4. Time 4, this whistle goes. This whistle went ages ago, time 1. So activity C can kick off at time 1, activity B can kick off at time 4. So this event signifies that A, B and C have all finished. So the earliest that can happen, well, 3 add 4 is 7. That's the earliest that could finish. 4 add 2 is 6. So at time 6, maybe B's finished. And obviously 1 add 2, that's really small, 3. So at time 3, C could have finished. But you need all of them to have finished. So you need the biggest one. Because you can't have C finishing, this whistle going, and then kicking off, because they need A and B as well to finish. So you need the biggest one. So you add up all 3, biggest is 7. So you put that at the top. Now, one of the hardest things is tracking what you're doing. So I like to get students to do a little thing like this, just to show that they've considered how many things are feeding into that event. So 1, 2, 3 things, and then in your head, 3 add 4, 4 add 2, 1 add 2, what's the biggest? Write it in. Okay? Ready to have a go? Okay. There you go. So start with a 0, that's it.
4
Yep.
means this must be 6 and this must be 7.
Yep.
But I've considered that. And considered
Yes.
that.
Now, the only thing I would say about your considering is that we are going to have to do a backwards pass as well. So what you're considering at the moment is the things going into an event. So it's like at the moment, rather than considering these activities, what you're considering is more the input into this event here. So I would put a little scribble there, and then a little scribble here, because it's the event that dictates everything, and then there's one here.
Right.
Yeah? So you can see that we've still got another 2, for example here, another 2 sticks, activities coming out of that event, but they're outputs, not inputs. So the fact that we haven't scribbled on them is going to mean that we're going to consider them when we do the backward parts. Does that make sense? So it's the input. So if we jump forward to this event here in the top right, how many inputs are there in there?
Right, so there are 1, 2, 3 inputs.
Yeah.
And the largest input, 6 plus 6 would be 12.
Yeah.
7 plus 1 is 8.
Yeah.
And 9 plus, well,
We haven't
I have
done
to go
that one yet.
way,
Yeah, exactly.
So I can't go to that yet. But
Yes.
at the moment,
Yes.
the largest would be 12.
Excellent. But we can't do that yet, like we said, because we haven't done this one.
Yes.
And this feeds in. So what we need to do is let that one wait a minute,
Yeah.
that one up there, while we do this green one.
Okay, so the 7 plus 9
Oh, okay.
we produced 16.
Yeah.
And that's
The only input there.
And then input it here.
Yeah.
So the largest is 20.
Yeah, and we did consider that one, and we did consider that one.
Yeah.
And then this last event only has one input.
So it's 29.
Perfect. So that's a forward pass, and that means that the quickest the job can get done is 29 days, hours, whatever it is. Okay, backward pass. So this time we're doing small. So you're going to an event, looking at, and I tend to use this wiggly line for backward pass,
Okay.
just because it distinguishes it from a forward pass. So we've got 3 things coming out of this event. So you look back, and we say, right, so 14 at the bottom here. If we've got to have this whistle go by 14, absolute latest, and D is length 3, then the absolute latest that this one could go would be 11. We've also got this one, 12, but that's 8, that's 4, so the latest it could go is time 8.
Yeah.
And then this one is 16, and that's length 4, so the latest it could go is 12.
Yeah.
Now, the trouble with it going at 12 is that if it goes at 12, then 12 add 4, so H happening, would be 16, and then we've blown the whole project. So we need the smallest one so that everything gets done by the time the next whistle has to go. So we're looking at the things coming out of the event, and then counting backwards, and then choosing the smallest. Okay? So if we start with the 29,
Yeah.
at the end, so the
That
29
going.
can go here.
Ah. Right. So that will
And
go
we're
to
doing
20.
Yes, but
and
we're
that's
doing
a
a backwards pass
pass.
now, so we're doing the bottom.
Ah, I see. Right. So,
Yeah. There's only one thing going out to consider. So 29 minus 9, 20, yeah.
20,
And then go
yeah.
to any event you like and look
Okay.
at the things coming out of it.
right. So if we went this way, we
Yeah.
get 16. If we went this way, we would
How many
get
things are going out of that event that you're at now? So you're currently at this event, yeah?
Yeah.
How many things are going out of that event?
1,
Out.
2.
2. 2 are going out, so you need to consider both.
Okay.
So you need this considered and this considered. 2 things.
Right.
Right.
So 20 minus 1 will produce the 19.
Yeah.
16 minus the 9 will produce the
7.
7. So we need the smallest number.
Yeah, that's
so
it.
it's the 7. Right.
So you go to an event, have a look how many things are going out of it.
yeah.
That's how many things you have to think about.
Okay. And for the F, if we consider there, so that will go to 14.
Yep, because only one thing is going out of that event.
Right. And then at B, that will go to the 4 considered. Ah, but I also need to check
Yeah.
this. If 14 minus 2 is 12, so
Yeah.
obviously the 4 is smaller.
Yeah.
And then that goes back.
Yeah, yeah. I think that the danger with this type of network is that you want to think through it like a flow. So, for example, you were saying you did this one here, and then you wanted to think of this as B, and then arrive here. So this was the thinking process here. Now, actually, the whole thing is driven by events. So you're not coming from something you've done and thinking in a kind of flowing way through the network. You're bouncing around the events. So we could have done we're thinking, right, this event here, there's only one thing going out, consider that. Now bounce anywhere you like. So this event here, there's only one thing going out. So I'm looking at the event itself and how many things are going out of it, rather than thinking, I've just done this one and I need to think in that direction back up through the network. So you're more sort of bouncing around the events, considering them in isolation almost, how many things go out or how many things go in on a forward pass. So once we've filled it all in, got all these numbers, then we can think about the float of an activity. Now the float of an activity is whether or not it can be delayed, and if so, by how much without affecting the project. So this J, for example, it has to go earliest 16, it's got a length of 8, doesn't have to finish until 27, so you can kind of think of it like this, moving about. So it could start at 16, it could be delayed again, it could be delayed again, there's no issue. If it gets delayed again, we've got an issue because it's not finishing by 27. So the float is how much it can be delayed. And the way that we work it out is we do 27 minus 16. So that's how much time J has got to be done in. And then we take away the 8, which is the duration of the actual J, and that leaves us with the float. And it's usually days, hours, weeks, minutes, whatever it is for that particular project. Okay? So we're going to stick the floats on here, on our network that we've already done. We've done the forward pass, we've done the backward pass, and we're going to put the floats on. So can you see what the float of A would be? If you talk and I'll write. What do we need to do for the calculation for the float of A?
So...
So what's the latest it has to finish by?
4.
4. Yep, this here, 4.
Right.
Okay, what's the earliest it could start?
0.
0, that's that 0 there.
Okay.
And how long is it?
So it does take 4, so there is no float.
There's no float at all, exactly. What about C? What's the latest C has to finish by?
Right, okay. So it has to finish by 14.
Yep.
It starts at 4. So...
It can start at 4,
yeah.
It doesn't have to.
So we have a float of 8.
Yes, because we have to take off the 2, and then we get a float of 8. Exactly. So let's try and put some floats on. Any more floats?
For B, there's no float.
No float for B?
For F, there's no float.
For F, there's no float.
There's no float because it's 20 goes from 14.
Yes, 20 is how late it has to finish by, but it could start at time 6.
Ah, see.
It could start at time 6.
Right, so it actually has a float of 14H as well.
As well, yeah.
Okay. So at E,
Yeah,
can start at 7.
Yeah.
It's got 1, it goes to 20.
yeah,
So it's got a float of 12.
yeah.
Okay. And at D, 7 to 16. So yeah, that's no float.
No float.
And then to G, no float. And for H, obviously no float.
No float, that's it. That's the floats, right? So a critical activity has got no float. It's critical because it can't be delayed. So it's critical. So our critical activities are A, B, D, and whatever that one was under there that I can't see
C.
anymore. C. No, C's over there.
G.
G.
Yeah. G.
And a critical path is a path from the source to the sink, and it goes through the critical activities. So this is the critical path through this network. Okay, so that's what a critical path is. And that's our objective, is to find the critical path. Critical path is the longest path in the network. So, a lot of information, but an event has an early time, which is the top, which you get from the forward pass, which is the biggest of all the things feeding in. It's also got the late time at the bottom, which is the smallest of all the things going out, essentially. The float is the difference between when it can start, when it must finish by, and how long it is. A critical activity has no float, so it can't be delayed, otherwise the project will be delayed. And a critical path is a path through the network from source to sink through critical activities. And a critical path is the longest path in the network. That's it. Let's try one. So, all yours. Your very first CPA network.
Right.
You're going to find a critical path.
So we're trying to try and find the longest first, aren't we? So the longest is the top.
Yeah.
And I've considered that.
Yeah.
Now I'm going to
Yeah, good, yeah.
So that goes to 7.
Yeah.
And
Yeah, easy when only one feeds in. Yep.
And then consider here. So that now I'm considering that would be 14, but I need to consider
Exactly,
those
yeah.
first.
So if we get rid of that, because there's obviously
haven't-
two
yeah.
feeding in there and we can't do two yet.
So I'm going to feed these
Oh, hang on.
first. So
Yeah. So there's two feeding into that one.
yeah, so that's either going to be 13
Yeah.
or 13 again. So
Yeah.
it is going to be 13.
Yeah, and you did consider that
Yeah.
13.
And then, so the 13 plus the 8 is 21, but also I've got
That's
the
that
8,
one.
and I'm considering that as well. So it's still going to be the G method.
Excellent.
Which is
So
21.
now we start with the 21 on the bottom.
Yeah, and we need to do the
And
reverse.
so this is
B.
21 to start. Go to any event you like and look at how many things are going out of it.
Right. Out of it.
Yeah, out of it. So that one, there's only one going out, so there's only one consideration.
Right. So that would be the 18.
Yeah, 21 minus 3 is 18.
Okay, and then we've
That
got
one's only got one
thing
going out of
coming
it.
out. Right, I understand. So that's going to be 13
Yep.
as well.
Yep.
And
Next event, any event you like.
right, so if I picked at F,
Yeah.
this has one thing
Yeah.
coming out of it, so
Yeah.
that means that would be
Yeah.
9. And then if can I continue or do
You
I
can
have
go to any event you like. The only problem will be if you realise that one of the considerations is impossible because you haven't done it yet. So, for example, if you now choose this event,
Yeah,
you go, right, I've got 1, 2, 3 things coming out of it.
yeah.
I've got 18 minus 9, 9 minus 7, and then, oh dear, don't know. So you can't actually do that one yet because you haven't got enough information to do it.
So do you recommend
so
doing
this
it
one you can't do it
sequentially like I'm doing it? Or because you said, oh, I can pick any event,
Yeah.
but I might as well.
Yeah, it's a
Do
sort
it
of
in order like
sequential,
I
isn't
do.
it? But then you did, for example, you did this one before you did these two,
True.
didn't you? So you're not really sort of passing in this direction back. You are bouncing around
Right.
however you like. It's just that you can't do one that is dependent on another one being done first.
Right.
That's all.
Okay. Cool. So if we go back to E then, so we can see there's one out.
Yeah.
So that means I have the 6. I've forgotten if it's subtracting from this number.
Yeah, it's
isn't it?
all the bottoms now.
Right. So 7 again, and then one thing coming out of there. So that would go back to 5.
There's 3 things coming out of there.
There's 3, so I need to consider. Right. So 9 minus 7, that would be 2. So let's figure that out. Could be 2, and it also could be 9. So
Yeah.
it's going to be the 2.
Yeah, because it's the smallest.
And it goes back.
Yeah,
Right.
because there's only one thing.
Right.
Okay, so then we do our floats.
Okay. Right. So between A, there is no float.
Yeah,
Now, if I compare A to D, there is a float of 16.
yeah, good, because 18 minus 2, hang on. 18 minus 2 is 16,
Yeah.
but D is length 9.
Ah.
So you've got an activity of length 9 bouncing around between.
Sorry,
yeah?
of course. So I need to subtract,
Yeah,
so that'd
yeah.
be a 7,
Yeah,
right?
perfect.
And if I also compare it with C,
Yeah,
I've got, there's definitely no leeway
yeah,
there.
because 9 minus 2 is 7 and C is 7, so none.
Right.
Yeah.
And the 7 and the 5 is no leeway there
Yeah.
either. And then if I continue on to E, 7 to that gives me 6 and there's no leeway there. There is between F, there's no leeway there.
Yeah, because 9 to
And-
13 is 4 and F is length 4.
Yeah. And for H, 11 to 21, there's some leeway there. So
Yeah.
that's 10, so
Yeah.
that's leeway 7.
Yeah.
And then finally, from the G, there is no leeway at all.
Yeah.
So if I was to draw a critical path, there are 2 critical
Yeah,
paths.
yeah, perfect. There are 2 critical paths. It's on thingy.
Thank you. So there's this one.
Yep.
And there's also straight down.
Yep, exactly. So we've got 2 critical paths. A, B, E, G is one critical path, and A, C, G is the other critical path.
That's
Done.
A, C, F, G.
Yes,
A, C.
that is what I meant. A, C, F, G.
Thank you.
Perfect. Sorted.
Thank you.
No, I do not want to go forward.
Let's start.